In this lesson, we're going to look at the Scala collections classes. And the way I'm going to do this is that this page comes from the Scala cookbook, and this is an online version, and you can see it up here. It's on the O'Reilly Learning platform, and this is Scala cookbook, second edition. And one thing I've learned as I work with other programming languages is one of the first things you want to know after you see the syntax is what are the collections? And so that's the purpose of this chapter. And as I note right here, there are 5 chapters on the Scala collections classes, and I believe it's over 100 pages. That's because the collections, like as I say, are so important to any language. And Scala's collections are really rich and deep, and so they provide a lot of variety, and that's why I cover so much in the book. And so even though the Scala collections are really rich, really deep, you can really simplify things right away, especially when you're first starting. For instance, if you want an indexed immutable sequence, vector is recommended as the go-to sequence. And similarly, if you want an indexed mutable sequence, you use array buffer instead. So it's real simple. If you want an indexed sequence, then you just say, well, do I want it to be immutable or mutable? And if it's immutable, go with vector. If it's mutable, go with array buffer. And even the most experienced Scala programmers still use these types. So you start with these on day one, and you'll still be using them as you go along. And I'll also explain this more as we go along. One thing I try to make clear in this next section is that Scala is not Java. So if you happen to be coming to Scala from a Java background, the best thing I can recommend is just to forget about the Java collections classes. The only time you want to really know about them is if you're using Scala and Java on the same project. But if you're going to start a new project and just using Scala, just forget everything you know about the Java collections and just dive right into the Scala collections. And I can tell you where I put it down here. In my own experience, I came to Scala from Java, and I kept trying to use the Java collections classes. And I mean for like weeks or maybe even a month or two. And this was a huge waste of time because I kept trying to make the Java collections work well in Scala. And they do. I mean, it actually works out amazingly well. But it's a real big waste of time because what you want to do is if you use the Scala collections, what turns out is that you're going to I noted here, you're going to really rarely write or read custom for loops. You know, I wrote custom for loops for 10, 15 years in Java. And then once you get into Scala, it's like all those for loops go away, like 95, 98% of those custom for loops go away. And that's because Scala has all these built-in collections methods like filter and map and for each and so on. There's, over 100 methods on each type. So again, the best thing you can do is just forget about Java collections and focus on the Scala collections, and I'll try to make that as simple as I can here. One thing to know is if you want to try to understand the collections hierarchy, I'll start with a table here and then we'll start looking at some images. But the basic types are in this package here, the scala.collection package. So these are the super classes or super types, as I note right here. They start up here and then they branch off into immutable collections in this package, and then mutable collections, the ones you can modify are in this package here. So that's starting at a really high level. Another thing to know, and I kind of mentioned this here just so you won't freak out, again, the collections hierarchy is really rich, really deep, and really wide, and you'll see what I mean as we go along. One example of this, I've already recommended that we use the vector class, and if you happen to go over and look at the Scala doc, you'll see under these linear supertypes, you're going to see all these types here. And I think do I have that open here? Here we go. So this is the vector class Scala doc page. And what I'm showing in the book, like if you click right here on these linear supertypes, and these are the types, more precisely, they're traits that make up the Scala vector. And frankly, I have no idea what most of these are. I know what an iterable is, and I know what a vector is, so I'll talk about that more. But a key here is that these are composed with Scala traits. All these little traits like serializable and what's another good one? Index seek. These are all traits, and they have just the minimum amount of methods that are needed for that trait. And then what happens at the end is you mix them all together, and then you get this Scala vector class. But what I try to make clear is don't let this freak you out or anything like that. Don't let it be too imposing. Again, I have no idea what most of those things are. I just use a vector like this. So you create a vector, you say val x equals, vector 1, 2, 3, and then you can use these methods here on a vector. And to that point, we can go over here. We can just say, how about val, we do val nums equal vector 1, 2, 3. So nums is my variable, it's a vector, and as you can see, the type is a vector of int right there. And now if I do nums dot and then a tab, you'll see there's, what is it now, 183 possible methods. So I'll say, yes, I do want to see all those methods. So these are all the methods that are available on a vector class. And we'll get into some of these methods. I think there's probably like 10 or 20 methods that you use maybe 95, 98% of the time. And then it's good to know that all these other ones exist for the times when you need them. But again, the key about all these methods right here is that you're going to use these methods instead of writing custom for loops. And one other thing I want to mention right now is Scala's consistency. So that's how you create a vector. This is how you create a list. This is how you create a, what else do we want to do? Here's a seek. I can do a set, just like that. And then what else would I do? If I do an array buffer, and array buffer is mutable, so I would have to do import scala.collection.mutable.array buffer. But then the cool thing is, once I've done that import, I can create an array buffer in exactly the same way. So I just do this, show all these examples here just to show the consistency of Scala. So this table right here, and then this example here and here, give you an idea how things work so far. And next thing we'll look at, now we can look at some class diagrams, or in Scala, these are really type diagrams because some of these may be implemented as traits. And so now as we take more of a graphical look at this, way at the top, there's the iterable trait, and it also has a Scala doc page over here. The key to know about it is that it's defined in terms of an iterator, and an iterator is a thing that you can only use once. So I'm kind of assuming that you've seen iterators in other languages. We really don't deal too much with iterators in Scala, and instead we use all these methods that are built on top of an iterator. So this is really interesting. This is the iterable type, and you can see all these methods, and I could just keep going and going, that are built for the iterable type. And then we come back here, and now we can say, well, a sequence is a type of iterable, a set is a type of iterable, and a map is a type of iterable. And they all inherit all these methods that are listed over here. And again, before we move on, this is a look at a very high level. And I want to come back and just touch on one more thing. So an iterable, you start with the iterable, you can have a set and a map descend from those. A sequence, or seek, S-E-Q, descends from the iterable, and then a sequence branches off into index seeks and linear seeks. So a linear seek is like a linked list, and then an index seek is a vector. And now I'm going to start breaking these down into immutable sequences and mutable sequences. So immutable is something that can't be changed. Mutable is something that can be changed. The first table shows the immutable sequence hierarchy. And the important ones here, again, seek is the top level in terms of sequences. And I just mentioned index seek and linear seek. So again, under linear seek, we have list. Depending on your needs, you may also use lazy list a lot. And there's also queue over here. And under index seek, we have the vector. We use range a lot. And of course, we use strings a lot. And I may not remember to mention this as we go along, so I'll just go ahead and say it now. If I don't put a lot of emphasis on something like a queue or a numeric range or an array seek, that just means that we don't use it an awful lot. So when I say that we do use vector, we do use range, string, and list. Those are main types, and we use those all the time. All these other ones are specialty types, basically. And so again, these are immutable. And now when we come down to the mutable ones, the ones that we use here, where is it? Array buffer is the most common, far and away the most common one right here. We use these others for special needs, like string builder. If you've used that in Java, there's something, I can't remember what the name of it is in Java. It might be string builder or something close to that. So you might use that when you're working a lot with strings. The other thing to know here is, in general, a buffer is a type of a sequence that can grow and shrink. And so then an array buffer is built on that. An array buffer is actually backed by the Java array. So we don't really use Java array directly. We use array buffer instead, and then there's an array in there behind the scenes. And a list buffer is kind of an interesting creature. It's a combination of a linked list and a buffer. So if you wanted to use a list type, but the list was going to keep changing a lot, what you would do is you'd use a list buffer, and then when it stops changing, you would convert it to a list. That's got the purpose of this type here. Next, another type that we use all the time is the map. And a map is a collection of key value pairs where all the keys have to be unique. And as I scroll down a little bit, again, I break this into immutable types and mutable types. And frankly, what I do all the time is I use this map for immutable and I use this map for immutable types. So again, here you have to imagine that you're importing scala.collection.mutable.map, and then you can use this one. And you can use this map by default. So this is a good time to mention that all of the immutable types are available or accessible to you by default. And then if you want to use a mutable one, you have to import them before using it. But again, I primarily focus on using the plain map in either case. And we come over to this part of the tree here. This one's interesting. Again, I don't use it a whole lot, but these are used when you want to have a sorted map, meaning that you want to be able to get the elements out in the order in which you put them in or some special order. So a vector map, both of these are a combination of a sequence and a map, which is really kind of cool. So what happens is you'll sort a map somewhere over here, and then you'll store the elements, typically in a vector map. You can also use a list map, but a list map works like a list, so you want to make sure you're always inserting at the head. So the vector is more flexible generally. And when you're doing the same thing down here, you'll use a linked hash map. And again, this is for sorting purposes primarily. A set is a collection of unique elements. So you can go ahead and put in, if I go over here, for example, and then we say set, I could do 1, 1, 1, 2, 2, 2, and 1, 3. And then you'll see what I mean by unique elements. I attempt to put all these elements in right here. And then when the set is created, it actually only contains those unique elements right there. So that's a set. And by the way, that's the immutable set by default. And if you want to use the mutable one, you'd have to import it. So I use the set a lot by default. And then these are other special purpose sets that you might use from time to time. And those are immutable. And then these are the mutable ones down here. So that was a high-level overview of the types in the Scala collections type hierarchy. Now, the first thing I do, the first recipe in chapter 11 of the Scala cookbook is how to choose a collections class. And I note there's 3 main categories, and you just saw those: sequence, map, and set. Occasionally, you use other ones. So you use a range, stack, and a queue, and a few other types work like a collection, but that's just should be more of a side note. If you assume that you want to use the sequence, you only have to make 2 decisions. One of those is, should the sequence be indexed, which allows that rapid access to any element, or should it be implemented as a linked list? And then the second one is, do you want a mutable or immutable collection? I note here that this began in Scala 2.10 and continues today. And I think 2.10 came out roughly like 2011 or 2012. So we still have the same recommendations that we did way back then. And so you come to this table, and again, this is just for sequences. If you want an indexed immutable sequence, you use a vector. If you want an indexed mutable one, use an array buffer. And if you want a linear linked list that's immutable, use the list. And if you want the mutable one, use the list buffer. And what I do is, if I know I'm going to have a huge list, it's either going to be a vector or an array buffer. And then that just depends on whether I want it to be immutable or mutable. And then I note in the table that follows that while those are the general purpose recommendations, there's many more types that you can get into. So one, like the lazy list right here, and then I organize this into indexed and linear. A lazy list is similar to a list, but it's lazy. So to demonstrate this one real quick, let's go ahead and go over to the REPL. So I'm going to do a 1.2. All right, let me do it differently. Can I do a lazy list here? There we go. So I can do a range. And you can do a 0, and then you go to int.max value. So that creates a lazy list, and note that right away it just comes back. It doesn't do anything, it comes back and it says lazy list is not computed. And that's what I mean by lazy. It actually doesn't do anything. It just makes a note and says, okay, this is what you want. And if you ever force me to do some work, I'll go ahead and do that. Conversely, we can make the system crash very easily by saying, I want I want a plain list, not a lazy list. And then I'll create a range the same way, and it goes from there to max value. The first thing to notice right away is that it actually is doing work right here. Notice that it's not returning the prompt. This takes on my computer somewhere around 15 to 25 seconds before it crashes and runs out of memory. So I'm just going to let that run. But I just wanted to note that's the difference between a lazy list and a plain list. So lazy list, nothing happens right away. A plain list, it tries to go to work and then it's going to crash eventually. As I come back here, there are more types, and I can let you read these at your leisure. You know, queues, first in, first out. Range we use all the time. Vector we use all the time. Then the most common mutable sequences are shown here. And again, I have the same types of categories. Somewhere around here, I note that a buffer is important because it's a type of sequence that can grow and shrink. And that's why it's in the mutable section, of course. Array buffer we use all the time. Array is kind of a weird one in Scala. We use an array all the time in Java, but in Scala you don't use it, you use the array buffer instead. And that's because array is kind of weird in that it's immutable and then it cannot grow, but it's also mutable in that the elements inside of it can change. It kind of has one foot in each world. So there's like one foot in the functional programming world where the array cannot grow, can't be larger, but then it has another foot in the mutable world where the elements inside of it can be changed. So it's kind of a weird creature. So we use the array buffer instead, and it is just completely mutable, meaning that the size can change and the elements inside of it can change. So that, again, this is your go-to class for immutable index sequences. Now in this table, we get back into traits that are commonly used, like in library APIs. And I showed these before in the tables and the graphs that I showed earlier. So I'm just kind of showing these again, but in a different context. So an index seek is a sequence, and it implies that random access of elements is efficient. Whereas the linear sequence is like, yeah, you don't want to access elements randomly. You really just want to work with the head and the tail. The base trait of seek doesn't make the distinctions that these two do. The reason this is important is if we go back over here and I say, this is some function. So I'm going to create some function. Okay, so I'm creating a function. Its name is some function. It doesn't take any input parameters. And what I'm trying to talk about is right here. And that is, what does your function return? And this is an indication. This guy right here is an indication to other developers that call your function that you're trying to say something important here about the sequence that's returned. So when it's a plain seek like this, if you look at this table here, I'm not making any distinction. I'm just saying this is some sort of sequence and it may be indexed or it may be linear, and that's not important. However, if I do want it to be important, then I would say this is an index seek. And then this is where the fast random access comes in. And conversely, if I don't want to do a sequence or an index sequence, then I would come back here and I could say I'm giving you a linear seek, which is like basically a list. So you could even put a list here if you wanted to. And now as we come back here, iterable is very high up in the chain. And I note that if you're familiar with Java, this is like the collection type in Java, very, very high up on the type hierarchy. So this says very little about what you're returning. This one just says it's a sequence. And then again, I already made these notes here. Next up, if you want to choose a map, as I mentioned, I probably use the base map classes 95, 98% of the time. But when you need some specialty types of maps, then those are listed here. So you can see I'll have descriptions of each of those over here. And similar to a map, I have some suggestions here about choosing a set. So when you're choosing a set, again, you have mutable and immutable. And I probably use the basic set somewhere around 90% of the time. You can use a sorted set whenever you need to return the elements in sorted order. That shouldn't say by key, they're just sorted order because this is not a map. Linked hash set stores them in insertion order. And then you get into all these other types down here, all the other possible sets here. So I'll let you read those at your leisure. And then one last thing I want to note about choosing collections. Another way we think about these is whether the collection type is strict or lazy. Now, if you happen to be familiar with Apache Spark, then you already know about lazy collections because everything or most everything in Spark is lazy. And I showed laziness a little bit with that lazy list example. So basically, a lazy collection doesn't do anything until it's forced to do something. And it's forced to do something by a transformer method. And this includes methods like map and filter, etc. Any method that transforms the input or given collection to a new output collection. And as you saw with that list example, in a strict collection, memory for the elements is allocated immediately. And the example that I noted earlier is that I can create a lazy list right here. And when I hit enter, you'll see that nothing happens. It just, comes back right away and it says I'll compute those things later. Conversely, when I do a list, if I do this, if I took that off, we'll go ahead and do that and let that crash. But again, lazy list is lazy. Nothing happens right away. A list is strict, so everything does happen right away. And in this case, it's going to try to create this list. And again, it's going to eventually crash when it runs out of memory. And the final note here is that all collections in Scala are strict except for two situations. And that is a lazy list is a lazy version of a list. And then when you create a view on a collection, the transformer methods on that resulting view are lazy. So let me copy that just so I don't forget that over here. Copy that. And then let me come back to the REPL and I can paste this guy in here. So we can say val x of s equals that view. And that comes back right away and you see the familiar not computed. So that's a great indication that that's lazy. And there's a slight mistake here depending on how you want to categorize things, but a range is also lazy. So I could say this creates a range. So I'll create a range from 1 to int.max value. And you'll see that this guy comes back with a description right away. And you can tell from how quickly it came back that nothing really happened right there. So it creates this range lazily. And conversely, if I come in here and then I try to force this guy to be a vector. So the distinction about whether I'm right or wrong here has to do with whether you want to consider a range to be a collection or not. And a lot of people don't consider a range to be a collection type until you try to force it to be a vector or to be a list or something like that. And that's why I don't include it here. As a brief addition to this video, I want to add one more thing. So this is the second recipe in chapter 11 of the Scala cookbook, which I'm looking at online on the O'Reilly Learning platform. And this one is understanding the performance of collections. And this is also important when you're choosing a collection. So that's why I want to cover this as well. And the examples I come back to all the time is comparing a list to a vector, because a list is implemented as a linked list, a singly linked list. If you want to access something like the 1 billionth or the 100 billionth element, you're going to have to go through all those elements just to get to that last one. Whereas if you want a vector is indexed, so you can access that through just a few hops. That's much, much smaller than trying to access it through there, much, much faster to access the 100 billionth element in a vector as compared to a list. And that's going to be shown in these tables that follow. The way they did this on the Scala website, and I copied this information here from the Scala website with their permission, I should say, is that they created these tables. So basically, this one's saying that an append operation on the vector is EC, which stands for effectively constant time. And then what happens is we scroll through here. So then this table has descriptions like that, like this operation takes constant time. This one is effectively constant time. And they add a little caveat that this might depend on some assumptions. Again, there's more things here, and then you have logarithmic time and that type of thing. So then what I want to do is just come to this table, and then so this shows performance characteristics for sequences. And when we come here to the vector, you'll see that for all these operations that are listed up here, the vector has effectively constant time for all of these things, whereas a list is constant time for like head and tail operations. But other operations like apply and update are going to be linear. And Prepend is constant, which is good. So when you use a list, you always want to prepend elements to the front of it. But when you append elements to the back of it, that's linear, and linear is bad. That's slow. So that's when you get into 100 billion elements. If you want to append one to the end, good luck with that. So I share this information here. These are all the immutable types, and then these are the mutable ones here. And as I scroll down, then I do the same thing for maps and sets, the different types of maps and sets. So you can see this information in the Scala cookbook, and you can also see this information on the Scala website, which should be this link right here. There we go. So it's the performance characteristics page on the Scala website.